So the next speaker is Fabio González from the Universidad Nacional de Colombia. And yeah, let's give him a round of applause.
Okay. So thank you to the organizers for organizing this great event. Probably, yeah, I will say this is the most important, biggest event on Latin America on artificial intelligence so far. So this is really, really, really important for the development of the field in our region. Yeah, doing research on anything in Latin America is not easy. So yeah, everybody knows what I'm talking about. So yeah, it's very good that we can have these quality presenters and researchers here. So that's really encouraging. So I come from the National University of Colombia. That's the biggest, oldest public university in Colombia. And this is the Bogota's campus. You can see it's like an owl. It's a nice campus. And there we have the School of Engineering, and our department is the Computer Systems and Industrial Engineering Department. First, I just want to show you this. This is like the history of artificial intelligence research in Colombia. So actually, National University has been involved on doing artificial intelligence research for a while. This was the first Congress on neurocomputing during the 90s, at the beginning of the 90s. And that's important also to take into account, because, I mean, nowadays, you really don't have to justify that you are researching in intelligent systems or machine learning, because that's a hot topic, right? But yeah, 20, 30 years ago, that was kind of something really niche, and it was kind of frivolous of researching on these kind of topics when you have all these kind of problems here in our countries, you know. But I want to highlight that it is very important to work on topics that not necessarily are that have an immediate impact, because who knows what the future will bring, and that in some way prepare us there for the revolution of artificial intelligence. In fact, there are several groups there, our department, that work on related topics. This is just an example. This lab works on bioinformatics, that nowadays is also an area where you applied a lot of machine learning intelligent systems. Also, there is a group working on artificial life, robotics, a group that works on big data and data mining, like we used to talk, we used to call this area some years ago, but it's basically the same. Algorithmic trading and applications. So just to let you know, if you are interested in any of these topics, I can also be the channel of communication with those groups. And this is our group, which is the Machine Learning and Perception and Discovery Lab. It's a lab with a focus on machine learning and its applications. And these are like the focus problems that we had been working for a while. Multimodal learning, I'm going to talk a little bit about that later. Large-scale learning and representation learning. I mean, that used to be like a niche area of work, but nowadays with deep learning, yeah, that's what everybody's working on. So, but that's also that has been our interest for a while now. different areas of application, biomedical information, mainly images, information retrieval, computer vision, lately test analysis and understanding as well. So we are pretty much interested on any area where we can apply this kind of tools and different kind of methods. Definitely deep learning. I mean, who is not working on deep learning nowadays? I mean, if it's working on machine learning, yeah, we had to. Before, we did some work on kernel methods, matrix factorization, etc. Nowadays, we are trying to combine like that old school. I mean, old school is like 10 years ago, 15 years ago. We are trying to combine that with deep learning and all that, but yeah, but mainly our work nowadays is deep learning. So one area of application is deep learning for biomedical image analysis. This is really challenging. There are differences between medical images and natural images. At the beginning of this revolution, most of the work was on natural images, so we were like at the right place at the right time. So we took notice of what was happening with deep learning, and then we applied that to what we had been doing for a while. That was analysis of medical images, in particular histopathology images. This is one of our papers from 2013 in MICAI, the most important conference on medical imaging. And at that time, that conference has like 400 papers, something like that. There were 6 papers on applying deep learning to different kind. I mean, 6 papers out of like 400. Applying deep learning to different kinds of medical images. Ours was the only one applying to histopathology images, and yeah, that nowadays, yeah, out of the 400, probably, I don't know, maybe 100%, I will say, because even if you don't work with deep learning, you have to compare against deep learning. Otherwise, your paper is going to be rejected. So, yeah, you have, I mean, deep learning is everywhere. So, yeah, we were kind of lucky, I will say, but, I mean, who will know that this is going to be this huge revolution? So, yeah, we have done a lot of work on that, applying these kind of methods to different kind of medical images. And that's, it has been really interesting. The main product, yeah, as Professor Shapiro was saying this morning, is papers, and sometimes it's difficult to see the direct impact of your work. However, anyway, I mean, it's important to do this. Yeah, and the recipe is the same. I mean, like, for instance, this convolutional neural network that you apply to different kind of images that have been labeled, and you want to detect some area of segmentation or detection, classification, etc. And yeah, I think that's important. I mean, anyway, I mean, exploring these kind of things is important at the beginning, even if the direct application to, for instance, to the kind of things that we have there in Colombia is not very clear, because most of the papers in biomedical, unfortunately, are not, I mean, just a small percentage is finally applied on the devices and the diagnosis protocols, because it takes time. So, okay, so this is another example of the kind of things. Oh, I just want to say that in this kind of work, we got several papers, 2 patents, etc. Okay, but as I was saying, probably those 2 patents, I don't know, I hardly believe that these 2 patents are going to be used in an actual device. But anyway, I mean, the patents are there now. Okay, good for the numbers, you know. Okay, but, yeah, this just another area of application. These are iFondus images. Same thing. So you want to detect some things which are with clinical meaning, etc. And the problem with this, okay, and then we apply the same formula of the convolutional neural network, etc. The problem with this is that now the competition is harder. For instance, Google is really interested in this. Okay, so and probably Jeff Dean is going to talk on Friday, probably is going to talk about what they have done with this. It's really difficult to compete with Google, you know? So, but anyway, that's good, that's good, that's good. However, I think we can find particular problems that we have. And this is a particular problem we have here, I mean in Latin America, and it's the fact that the kind of devices that are used to get these kind of images are usually costly. You find them in only some places, mainly in the large cities. And if you want to take this really to have a good coverage of the population, you need to think on things like this. This is a low-cost device that where you adapt a cell phone to a conventional cell phone to a lens. And this is very cheap. And the idea is to use this as a mechanism to take this to a broader population. So there are many, several opportunities. This is a kind of workflow, the different things that we can do with this kind of images. And I just want to talk about one thing that among others that we are working on, and it's guaranteeing the quality of the pictures that you can get with this kind of devices. So actually the problem is also that this device is used by a non-specialist. It's just probably somebody that has a technician or maybe a nurse. So, it's not an ophthalmologist. So if you want to guarantee the quality, the idea is that you have some sort of assessment, and ideally directly in the device, in the smartphone. So here our approach as well, convolutional neural network, et cetera, right, with some particularities, but that has to be inside the cell phone, which is a challenge. So this very interesting project. Now we are working with a foundation, and we are taking this to the field and with real patients. So probably we don't get as many papers with this as before, but probably this is going to have a higher impact. The other thing I wanted to comment is multimodal learning. I just want to say that this is like an incursion on trying to do the kind of things that other people are doing. So we invented like our own unit for doing multimodal fusion, and we applied this to for instance, to fusing tests and images, etc. And also, we can apply to different kind of data. And I'm proud of this. From an academic point of view, because it has been used for other researchers and important names. So that's also the kind of work that we do there. This is just a couple of examples of the things that we do in our lab. This is our team: several PhD students, master students, undergrads, and two professors, Jorge Camargo, Gusaula, also collaborate with me in the group. Thank you very much.
Anyone wants to ask a question? Question from René? Okay.
Yes.
For the applications in digital pathology, the images are really big, much bigger than the typical inputs used to neural networks. So how do you handle the size?
Yeah, that's a challenge. That's a challenge. So actually, part of the work that we have done with histopathology images, for a whole slide image, you may have like a 12 gigs image because of the size of the slide. So yeah, that's a challenge. We have an idea, and actually we got a patent out of that, but it was like doing some kind of Monte Carlo sampling on the image, so because even doing prediction was costly. However, after that, I mean, there has been a good work on growing convolutional neural networks from small resolutions to bigger resolutions. So something like full convolutional neural networks. Actually, that works better than our previous method, but yeah, that's still a problem that is being researched. Okay, thank you very much.
Thanks.